This ALEX topic has us calculating the pH for a weak acid titration where we're titrating the acid with a strong base. This is one of many different versions of this problem and the partner problems where we have a weak base and we titrate with a strong acid. So there are going to be several of these illustrations that seem fairly similar. In this problem, we're given the acid cyanic acid, HCNO, and we have a certain amount of it, 248 milliliters at 0.91 molar, and we're titrating with NaOH, and the question is, if we've added 101.1 milliliters of NaOH with a concentration of 0.79 molar, what is the resulting pH? So let's approach this in kind of a systematic way, and one of the things that I like to do first is go ahead and calculate the moles that are present. So let's calculate the moles for HCNO, and we're going to do that by looking at molarity times volume. And if you have molarity times volume for the amounts given here, we end up with 0.226 moles. We can do the same thing for the NaOH, and when we do that, we end up with 0.0799 moles. Now you can pause the video here and convince yourself that my math is correct if you wish. The next thing we should do is pay attention to what the reaction is going to be. So our acid, HCNO, is going to react with the OH part of the NaOH, and that's going to take a proton from the HCNO, giving us CNO minus and water. Now calculating the pH is going to depend on how many moles of all of these things there are present in the solution and all of that stuff. So let's keep track of that using a reaction chart, and I'm going to do this in terms of moles. So we start off with 0.226 moles of HCNO, and 0.0799 moles of NaOH. We don't have any of the CNO minus, and we just don't care about the water, so we'll just cross that off. Then we'll allow these things to react, and here we want to take kind of a limiting reagent approach. So we'll subtract off the limiting reagent, which in this case is the OH. So minus 0.0799 minus 0.0799 plus 0.0799. And we still don't care about water. Then, once we're all done, sort of at equilibrium or the final situation, we'll have 0.146 moles of the weak acid left. We don't have any of the OH, and we'll have 0.0799 moles of the conjugate base. So now we have to make a decision based on what's left in the solution as to what kind of problem it is. If we only had a weak acid, we would solve the corresponding weak acid problem. If we only had the conjugate base, we would solve a conjugate base problem. If we had a conjugate base plus a strong base, then the strong base would dominate the pH calculation. In this case, what we have a fair amount of our weak acid, and we have a fair amount of a weak base. So when we put a weak acid and its conjugate base together, that tells us that we're going to have a buffer. Okay? So we need to solve a buffer problem. So to do that, let's use the Henderson-Hasselbalch equation. So pH is equal to pKa plus log of the base form over the acid form. All right, so this base over acid, let me talk to you about that for a little bit. If we wanted to do that the righteous way to do this is to consider this to be a ratio of concentrations. Okay? But since the base and the acid are present in the same solutions, we can say that the ratio of concentrations is going to be equal to the moles of our base component divided by the moles of the acid component. Because the volume, if we thought of concentration as moles over volume, the volume is the same in both cases, and it's going to cancel out. So that allows us to just use our moles, even though something about that ought to bother us a little bit because we're not using concentrations. So let's fire this up then. So our pH is going to be equal to the pKa, which Alex tells us is 3.46 for this acid, plus the log of 0.0799 divided by 0.146. And if you do all of that math, you end up with a pH of 3.20. So 3.20 is our answer. That makes sense. We have a little bit more of our weak acid than we do of our weak base. So the pH ought to be just a little bit less than the pKa. Okay, that's it. I'll be back with another example shortly.